Let's start going over these together. And again, this is on Springboard page 95. Looking at 11 through 15. Number 11 says, what is the slope of a line that is parallel to the line with the given equation y equals 4x minus 7? Now, the notation that I've been using is that I first determine what the slope is of the given line. And I say that this slope is equal to what? 4/5. And so then my answer is, I say, well, okay, if that's my given slope, then the slope that would be parallel to it, in this case, would be what? The exact same thing, 4/5. Awesome. Number 12, what is the slope of a line that's perpendicular to the line with the equation of y equals negative 2x plus 1? Well, same thing. I'm going to first identify what the slope of this line is, which is negative 2. Then I'm going to write the different notation and say, okay, well, if that's my given slope, then slope that notation, perpendicular, would be equal to what?
1/2.
Positive 1/2. Good. Positive 1/2. All right, so good. I think that we're pretty comfortable with this whole slopes that are parallel and perpendicular. So we were asked to compare these 4 lines, line A, B, C, and D. And so they give us 3 different ways of determining slopes of lines. We could be given equations that are in the slope-intercept form, easily identifiable. Equations that are in a different form, and we got to manipulate them a little bit to figure out what the slope is, or given two points and using our formula. So for the first one, the slope is what? Is easily identifiable as positive 3/5. It is the coefficient of the x term as long as it's in slope-intercept form. Next, we got line B, and apparently the line B, it goes through or contains points with the coordinates of negative 6, 1, and 3, negative 14. So what am I going to have to use here to determine the slope? What am I going to have to use to find the slope of this? Just the slope formula, okay? Just the slope formula. So when I do that, I've got that my slope is equal to, you take y2 minus y1. The numerator is the rise. It is the change in y. So that's negative 14 minus 1, so that's going to give me negative 15. And then the numerator, sorry, the denominator, in the bottom denominator, is x2 minus x1. So when I have x2 minus x1, that's going to be 3 plus 6. So whenever you subtract a negative value, adding a positive. So 3 plus 6 is 9. But I always got to reduce my fractions. Keep your slopes and your fractions in simplest form. So these numbers are both divisible by 3. So my final answer is the slope of this line, B, is negative 5/3. Next, from there, we have another line which we are given the 2 points that it goes through. So a little bit quicker this time. We're going to be saying 11 minus 8 is 3, and then 4 plus 1 is 5. So the slope of this line would be 3/5. We all agree? 1 to 1. Now we're given this equation. It's kind of in standard form. The reason why I say kind of is because whenever I put my linear equations in standard form, I want my leading coefficient, A, the coefficient of the x value, I want that positive. So the fact that they have the leading coefficient of the x term, it's now a negative 5. I kind of disagree with that. I would want an equation in standard form to look like that. So it'd be positive 5x minus 3y equals negative 6. But anywho, what we got to do is we have to solve for y. Get y completely by itself and positive on one side of the equation. And when you do that, you're going to get that y is equal to a positive 5/3 x, and then we're going to get plus 2. Yes or no? Yep, cool. So what's the slope of the last line, line D? Positive 5/3. So I've tried to put them in all different colors so that we can keep them distinguished and apart. But now we need to describe the relationship between these. What I'm looking for is, are they parallel, perpendicular, or neither? By neither parallel or perpendicular, you have to know what that means. It means that they're going to intersect at some point, but we just don't know the angle that's formed by their intersection. Because if they're parallel, they're never going to intersect, whether they're positive slopes or negative slopes. They're just never going to intersect. If they're perpendicular, they're absolutely going to intersect, but they form right angles. So when it's neither parallel nor perpendicular, they're going to intersect, you just don't know what angles are going to be formed. You just don't know the angle at which they intersect at. So just make sure you understand, if that's what you put on a quiz or a test, you know what that means. So do we have any parallel lines? Which ones?
Line A and line C.
Line A and line C are indeed parallel. So let's go ahead and write that, making sure that we use correct notation. I'm going to put my answers above here. I know that you don't have that. You don't have the ability to just kind of block stuff off and write wherever you want, but you should be able to find some space on that page. So line A is parallel to line C. We all agree with my notation? Okay. From there, do we have any other lines that are parallel to line A or to line C? Okay, do we have any other, just like another separate set of parallel lines? No? Okay, so let's talk about some perpendicular. Do we have any perpendicular lines? What's up, Sam? Line B and line A is what you said? All right. Whoa, my bad. Yes, these two lines are perpendicular. Do we have any other lines that are perpendicular? Line C and line B. Okay. So the only ones that we haven't really compared, how is line A related to line D? There's no relationship. They're neither parallel nor perpendicular. And so when we kind of like step out of this realm of thinking about numbers and stuff like that, like we need to be able to picture and see what's happening and just make sure that all this makes sense. So when two lines are perpendicular, we've been saying over and over, they need to be opposite reciprocals. One needs to be positive, one needs to be negative, and they need to be reciprocals of each other. But I hope that you guys can like visualize that and why that's true. Because if I had two positive slopes that were different, well, they're going in the general same direction, even though at some point they're going to cross. Like they're going in the general direction. The reason why they have to have opposite signs is because when one is positive, the only way another line is going to come down and create a right angle is if that one's negative. That's why these signs have to be different, because I don't care about the angle or the steepness of that line that has a positive slope. The only way to have a line that's perpendicular, it's got to be a negative slope. And so that as those change, that's fine, but this arm is still staying negative as this one's staying positive as that shifts. So that's why they have to be one positive, one negative. And then the whole reciprocal thing, well, as this one, as the positive one, as it's rising up and running over and rising up and rising over, well, the one that's coming in the other direction, that has to be flipped. So as I rise up 2, this one's got to run over 2. And then as I run over 1, this one's got to go down 1, and that will ensure that 90-degree angle. So I hope that this stuff is, it's not just rules, but that it, yeah, it's like you guys can see this happening. It makes sense to you. Cool. The one thing I wanted to point out is that we should have talked about this last class, that here in red ink, we have, what we've stated is that two lines, line A and line C, are perpendicular to the same line. You see that in red ink? We're saying that line A and line C are perpendicular to the same line, line B. Well, if that's the case, then what we talked about last class, and I think I drew a diagram like this, where I said, okay, line B is there, line A is here, and it's perpendicular, and then also line C was perpendicular to the same one. And if that's the case, then what can you prove about line A and line C? That they're parallel. Did we talk about this last class? Sweet. So last class we talked about it at, like, it was strictly diagram, strictly visual. And we drew this and we saw, well, okay, cool, if that's a right angle, that's a right angle. All right angles are congruent. Therefore, if corresponding angles are congruent, then lines are parallel. And so we convinced ourselves that was true just using diagrams and corresponding angles and those theorems that we learned. Well, now we're seeing it with numbers. We're seeing it with these actual values, that if you have two lines, line A and line C, that are perpendicular to the same line, then they have to have the same slope. They're going to be parallel to each other as well. So same exact theorem, just two different approaches. One with strictly diagrams, one with numbers. Yes, sir? So red is the only one that has a negative slope, right? So which one was that? Which one was the one? So that was line B. So we can see that line A and line C are perpendicular to the same one. So this is a right angle form here. That's a right angle form there. And then the one that wasn't parallel and wasn't perpendicular to any of them is that one that's forming these non-right angles. So here, there's still angles being formed, and we're very familiar with that case where you've got vertical angles in linear pair. They're just not right angles. And same thing with this guy right here. Those aren't right angles, and those aren't right angles. So on a quiz or test, you would just say those are neither parallel nor perpendicular.